everyone. Sorry I couldn't be there with you today. I had a rough weekend. I actually fell down the stairs at my house and had to go to the emergency room, so I'm not quite mobile enough to be back at school with you today. But I will go through these notes with you so that you are ready for your homework tonight. Let's start with vocabulary. This is both the 2-1 and 2-2 notes put together, and we continue with our logic, kind of like we did the logic puzzles for homework, which I will give you the answers for when I get back. I know you guys are dying to know if you're right. So for our vocabulary, we're looking at a couple of different types of reasonings. Their names are inductive and deductive reasoning. Inductive reasoning is reasoning that uses a specific number of examples to arrive at a conclusion. Another way to think about it is inductive reasoning is based on observations or patterns. Sorry, my handwriting in this is not great. The other type of reasoning that we're going to use is deductive reasoning. Deductive reasoning is reasoning that uses facts and rules and definitions and properties, and what we'll be learning too, which are postulates and theorems. When we start writing proofs, we will be doing deductive reasoning. A conjecture is a concluding statement reached using inductive reasoning. So once we look at those patterns and we come up with some sort of conclusion based on those patterns, then we'll make what's called a conjecture. A conjecture is simply a statement. A counterexample is an example used to show that a given statement is not always true. It can be a number, a drawing, or a statement, and we'll look at some of those later on in these notes. A statement is a sentence that's either true or false, so that's not too tough. Sometimes we use the letters P, Q, or R to represent statements that we're looking at. The truth value of a statement is whether or not it's true or false. To negate something, kind of like if we're looking at negating numbers. If you have a positive 2, negating that is a negative 2. Negation of a statement is looking at the opposite meaning of a statement as well as the opposite truth value. So, take a look at the symbol going on here. It looks like a little tilde in front of the P. So if you put not P, it looks like this right here. So an example, if your statement P is a rectangle is a quadrilateral, well, that truth value would be true. But if we said not P, that would be saying a rectangle is not a quadrilateral. And that's false because we know that a rectangle has 4 sides, and any polygon with 4 sides is called a quadrilateral. Looking more into these statements, we have what's called compound statements. A compound statement is 2 or more statements joined by the word and or. When we use and, that is called a conjunction. In order for a conjunction to be true, both things about that statement have to be true. For example, Ms. Schmidt was the one to write these notes, and her birthday is on April 19th. So the statement, my name is Ms. Schmidt and I was born on April 19th, is true because her name is Ms. Schmidt and she was born on April 19th. However, a disjunction uses the word or. That's when one or the other things have to be true, but not necessarily both. So that example would be, my name is Ms. Schmidt, or I was born on March 6th. Well, because her name is Ms. Schmidt, and that part is true, even though we know this part about her being born on March 6th is false, it doesn't matter, but the truth value of that statement would still be true because one of the 2 parts is true. So in order for and to be true, both parts of the statement have to be true, but for an or statement to be true, just one or the other has to be true. So let's do some examples. We're going to write a conjecture that describes the pattern in each sequence. Then we'll use the conjecture to find the next items in the sequence. So if we take a look at example number 1, we have 8 o'clock a.m., 9:30 a.m., 11 o'clock a.m., and 12:30 p.m. Then here we have some stars with part shaded, and we have some numbers in the sequence for number 3, and some numbers in the sequence for number 4. So I'm going to ask that the substitute pauses this for a few moments so that you can talk with someone around you and see if you can come up with the pattern and the conjecture. I'll show you number 1. The conjecture would be that half an hour is added on to each time. I'm sorry, an hour and a half is added on each time. So your conjecture would just be a statement saying an hour and a half is added to the time to get the next time. So following that conjecture, the last item in the pattern as it is 12:30. So if I were to add an hour and a half onto that, we're looking at 2 o'clock p.m. So go ahead and try 2, 3, and 4 either by yourself or with the person next to you, and then the sub can go ahead and start this again and you can see what the answers were. Okay, now that you've tried that with someone next to you, I hope that you notice the stars on number 2, the point that is shaded changes in a counterclockwise direction. So if you think about a clock, counterclockwise would be the other way around. So notice with the first one you have the top point that is shaded, and then if we go counterclockwise, the next point is shaded, and then the next point in the counterclockwise direction, and then the next point. So I know you guys don't have this fancy shape tool to help you out, but I can draw a star with my shape tool in order to come up with the next image. And the next image would be this upper right point would be shaded. And then your conjecture would be something like the shaded region rotates 1 point counterclockwise each time. Hopefully you have enough room on your paper to not have to write on top of your drawing. And then if you take a look at number 3, 2, 4, 12, 48, and 24. So what I noticed here is we start with the number 2, and then we multiply it and increasing that number every time. So 2 times 2 is 4, 4 times 3 is 12, 12 times 4 is 48, and 48 times 5 is 240. You might have had to break out your calculator for that one. I know that I did. So if we did times 2 times 3 times 4 times 5, then we would need to do 240 times 6 to get our next term, which is 1,440. So for our conjecture, we could say the previous term is multiplied each time, and the number it's multiplied by increases by 1 every time. Looking at number 4, I hope you notice here that we were multiplying again, but this time we were cutting it in half, so we're multiplying by 1/2 every time. So 100 times 1/2 is 50, times 1/2 is 25, times 1/2 is 12.5, times 6.25, I'm sorry, times 1/2 again is 6.25, so I need to take half of 6.25, which again you have to break out your calculator for, and the next term is 3.125. And I'll leave it to you to write that conjecture because I only have 15 minutes to record this video, so I'm going to move on. Next, on the back here, example number 5, we're making a conjecture about each value or geometric relationship, and we're going to list or draw some examples that support your conjecture. So number 5, the sum of an odd number and an even number. Well, if we think of some examples, sum means addition, so an odd number, let's say 3, plus an even number 2, that gives me 5. I'll try a different example. Let's say I do the odd number 5 and add the even number 4 onto it, and the sum is 9. We'll look at one more example. Let's do the number 7, that's our odd number. Add it to another even number, let's do 2 again, and we get 9. So if you take a look at the sum every time, when we added an even and an odd number, I think the conjecture we could make is the sum of an odd number and an even number is odd. So that's how we would complete that conjecture. The product of two odd numbers. So again, let's try some examples. 3 times 3. Well, 3 times 3 is 9. Let's try some more odd numbers. Let's do 3 times 5. 3 times 5 is 15. And if we try one more, how about 7 times, well, 1 is an odd number, so let's do 7 times 1, which gets us 7. And then if you look at all of those products, you can again see that those are all odd numbers. So we can complete this conjecture by saying the product of two odd numbers is odd. So when you're trying to complete a conjecture or make a conjecture, you want to take a look at a couple of examples, because we said that this is inductive reasoning, and inductive reasoning is looking at patterns in order to complete those conjectures. Okay, let's determine whether these conjectures that were made for us are true or false. And if they're false, we're going to give what's called a counterexample. Counterexample just needs to be one very specific example where you're proving that the statement is false. So, in number 7, it says, if angle 2 and angle 3 are complementary angles, then angle 2 and angle 3 always form a right angle. I think that's false. Even though we know complementary means that those two angles have a sum of 90 degrees, they would also have to be adjacent in order to form a right angle. So I think we could draw an example. Here, let's call this one angle, and that's going to be 30 degrees. And then if I were to draw its complement over here, where it's non-adjacent, and that can be 60 degrees, those two angles are complementary, but they don't form a right angle because they're not adjacent. So that would be an example of a counterexample. Number 8, it says n is an even number, then 2n is an even number. That's going to be true. And a quick explanation for you there is because anything you multiply by 2 will give you an even number, because it will then always be divisible by 2, which is the definition of an even number. Number 9, if you have 3 points, A, B, and C, then A, B, and C are non-collinear. Well, that's not necessarily true, because we just took a test over collinear and non-collinear, and if we were to take these 3 points specifically and put them all on the same line, A, B, and C, especially if they were forming opposite rays, right, then those would be collinear. So that's a specific counterexample where we're saying they don't have to be non-collinear. They could be collinear. Our last example here, number 10, Amy was collecting data based on how many students were not turning in their homework each week in class. In week 1, 5 students did not turn in their homework. In week 2, 8 students did not turn in their homework. And in week 3, 12 students did not turn in their homework. In week 4, 17 students did not turn in their homework. So I noticed that each week, 5 plus 3 is 8, plus 4 onto that is 12, plus 5 onto that is 17. So I'm thinking if I add 6, because I did plus 3, plus 4, plus 5, if I add 6, then I could continue this pattern to say that in the next week, we'll do 17 plus 6. 17 plus 6 is 23. So we would say 23 students would not turn in their homework on week 8. Okay, that is all the time I have on this recording to go through your notes, but I will leave the notes key with the sub. I want you guys to go ahead and try these Venn diagram problems. I think that you're pretty familiar with Venn diagram problems, and then I'll have the sub read the answers out loud to you.